Okay, we are going to now Model 7. Model 7 is rarely comes out in examination, but it's a part of the pass question, which is coming out in 1990s and 80s pass questions. But is it in the syllabus? Yes. So how to do Model 7? So Model 7 is about proving equations. So they will give you an equation, then you have to prove that equations by using quadratic functions. Now we take an example of question number 12 directly. This is written that alpha and beta are the two roots of the quadratic equation, which is x squared equals to 2x minus 3. So you are given an equation. Alpha beta are the two roots of the quadratic equation with the x squared equals to 2x minus 3. So what you see now is this is known in the form of ax squared plus bx plus c. So I'm turning it to the 2x bring the other side is negative 2x, negative 3 bring the other side is plus 3 equals to 0. And this has a root alpha and beta. So since this is a root alpha and beta, that means I have the sum of the root and also the product of the root. So what is the sum of the root? Sum of the root practically is negative b over a, and negative b is a negative 2. Okay, b is a negative 2, so negative 2 divided by a is 1, so negative 2 over 1, and since there is a negative for the formula, we'll get the value as 2. Now we're moving into the product. Product, the formula is c over a, which is equals to, c is equals to 3, that means 3 divided by 1 is 3. So we got sum of the root and product of the root. So we got it. Now first part of the question. What's the first part of the question? They ask you to find the value as 1 over alpha square plus 1 over beta square. This is a straightforward question where what we do is 1 over alpha square plus 1 over beta square. We cross multiply. So we times this and step 1. So we got beta square. And alpha square times with 1, I got alpha square. Then I times the both denominator, alpha square plus beta square is the solution for single fraction. That means, and a fraction, summation of two fractions written as single fraction, it means we must use cross multiply. Then from here, you got alpha square plus beta square. Therefore, I'm using the formula of alpha plus beta square minus 2 alpha beta divided by alpha beta square. So now from here, we can substitute. What is alpha plus beta? Alpha plus beta is 2. So sum of the root is 2, so 2 square minus 2 times here got alpha beta. Alpha beta is a product, so which is a 3. So alpha beta is 3, so we got 3 here. So as product of the root, we got 3. So from here, I got down there, we got alpha beta square, which is a 3 square. So 3 power 2, I'll get 9. So the answer is 2 power 2 is what? 4. 4 minus 6 is negative 2 over 9 will be the value of 1 over alpha square plus 1 over beta square. Now we are moving on to section B, which is we need to prove alpha power 4 is equivalent to negative 3 minus 4 alpha. Now first thing, we should know how to solve this problem. So now I'm going to look at the equation. So what you all can observe from this equation. So what you can observe here is we don't have beta here. I mean, this is the equations based on alpha only. So what that means? It means I must eliminate beta. So that's why I have two equations. One's the sum of the root equation and sum of the root equations and a product of the roots equations here, which is alpha plus beta equals to 2 and alpha beta equals to 3. So from here, I'm going to eliminate beta. Beta equals to 2 minus alpha. Therefore, alpha beta equals to 3. So I'm substituting the beta 2 minus alpha into the equation here, which is now it turned out to be alpha times with 2 minus alpha equals to 3. Expand this one, I will be getting 2 alpha minus alpha square equals to 3. Now we are getting making alpha square as a subject, so alpha square equals to 2 alpha minus 3. So I got one equation, but this is not proving this equation. So again, I need to look what is actually the lag on between these two equations is. Here is alpha power 4, then this is alpha power 2. So to make alpha power 2 to become alpha power 4, I must square the both equations, the both sides. So now I'm squaring the both sides. That means 2 alpha minus 3 square root and alpha square b square root. Then I obtain alpha power 4. Okay, alpha power 4 because alpha square power 2 is alpha 4. And this need to be expand. So that means if a plus b power 2 expand, you get a square plus b square minus 2ab plus 2ab. Therefore, I'm squaring this 2 alpha. I got 4 alpha square minus 3 square root. I got plus 9. And 2 times 2 alpha is 4 alpha. 4 alpha times negative 3, I got negative 12 alpha. So I expanded this, I got this. Now, in this equation, does not satisfy this equation again. The problem is, in this equation, we don't have alpha square. But here we have alpha square. Therefore, I must eliminate the alpha square. Anyway, alpha square is actually 2 alpha minus 3. So I'm going to substitute the alpha square as a 2 alpha minus 3. And now I'm going to expand it. Then 4 times 2 alpha, I got 8 alpha minus with 12. Minus 12 alpha plus 9 equals alpha over 4. Now I simplify this, I got negative 3 minus 4 alpha equals to alpha over 3. Now this and this is the same. That shows that we have proven this part. Okay, now we are moving on to the question number 13 as a second example for model 7. Okay, in this question, they're given that alpha is one of the root of the quadratic equation x squared minus 3x minus 2, and prove that this equation given to you, alpha power 3 equivalents to 7 alpha minus 6. Now, if you look at this question, we are only given alpha as one of the root, but we don't have another root. So what and how we're going to do now? So anyway, since the equation is x squared equals to 3x minus 2, so we're going to write it in ax squared plus bx plus c. Therefore, we got x squared minus 3x plus 2 equal to 0. And we have alpha as one of the root. Therefore, the other root we don't know, but I name it as a beta. Now what we're going to do, we're going to find what is the sum of the root and product of the root. So when we talk about sum of the root is alpha plus beta, but which is equivalent to negative b over a, which is equivalent to negative, b is what? Negative 3 divided by a is 1. So I get negative 3 over 1 is equals to 3. Whereas for product of the root, I got alpha beta equals to c over a, and this is equivalent to 2 over 1, therefore equivalent to 2. So now I already got sum of the root alpha plus beta equals to 3 and alpha beta equals to 2. Now I'm looking at this equation now. Then I found out that this equation we have without beta. So that means I need to eliminate the beta. Therefore, I have a 2 equation here. Alpha plus beta equals to 3 and alpha beta equals to 2. Now what I do, I make beta as a subject, which is equals to 3 minus alpha. Then alpha beta equals to 2. Then we substitute the beta into the this equation where we got alpha and beta is 3 minus alpha equals to, open up, then expand, and we got 3 alpha minus alpha square equals to 2. Then we got 3 alpha minus 2 equals to alpha square. I made alpha square as a subject, but unfortunately the equation 1 alpha cube. So what you do, we times both sides with alpha. So when I times both sides with alpha and expand it, I'll get 3 alpha square minus 2 alpha equals to alpha cube. So now again we have another problem, is here got alpha square, but in the proving we don't have alpha square, so I must eliminate the alpha square, and I know that alpha square equals to 3 alpha minus 2. So what I'm going to do now is I'm going to substitute the alpha square as a 3 alpha minus 2, and minus 2 alpha equals alpha cube. Now these things we need to expand. So when I expand, I got 3 times 3 alpha, I got 9 alpha. 3 times negative 2 is negative 6 minus 2 alpha equals alpha cube. Then simplify, I got 9 alpha minus 2 alpha equals to 7 alpha. Then I got minus 6 equals to alpha cube, which is equivalent to the what they required. Therefore, we have proven the question number 13a. Now, that's how we prove it. To eliminate the beta in order to write the equation in terms of alpha. Now we are moving on to section B. So in this question, in section B, if you look at carefully, the section B question is required you to prove that 7 alpha square minus 3 alpha is equals to 4. Okay, if you want to prove this part, what you need to do is, I cannot change alpha square, 7 alpha square. As another way of solving this problem is by just assuming that 7 alpha square minus 3 alpha cube equivalent to, what is 7 alpha square? Alpha square, just now we have found out that alpha square is actually equals to 3 alpha minus 2 equals to alpha square. So I substitute the alpha square with 3 alpha minus 2. And I got minus 3 alpha cube. And alpha cube is 7 alpha minus 6. So I substitute 7 alpha minus 6 to the alpha cube. Now I expand. 7 times 3, 21 alpha. 7 times negative 2, negative 14. Negative 3 times with 7 alpha. I got negative 21 alpha. And negative 3 times negative 6 equals to 18. Now I simplify this equation. This equation being simplified, I got 21 alpha minus 21 alpha is gone. So negative 14 plus with 18 will give you 4. Therefore, we have proven 7 alpha squared minus 3 alpha squared equals to 4. This is another way of proving equation. So this is how we can take the steps that to prove an equation which is being provided to us in the questions. Now we are going into another example. This is the passe question. Okay, this is one of the passe question which came out in 1981. I think at this moment you're not even born yet. So in this question, the questioner says that alpha and 3 alpha are the roots of the quadratic equation, where the quadratic equation is x squared plus px plus q equal to 0. Show that 3p squared minus equals to 16p. So I know that the roots are alpha and 3 alpha. Therefore, the sum of the root and the product of the root, okay, the sum of the root is actually alpha plus 3 alpha equals to negative p. Because the negative b over a, so is p there, it's negative b over 1 is negative p. So I got 3 plus 1, I got 4 alpha equals to negative p. So I got alpha equals to negative p over 4. Whereas for the product, I got alpha times 3 alpha equals to q, because c over a. C is q and a is 1. So c over a is actually q. So 3 alpha squared equals to q. What is alpha? Alpha is negative p over 4 squared equals to q. So when you square it, negative p squared is what? P squared. So 3p squared, and 4 you square it is actually 16, and the 16 is a denominator. Bring it to the other side, you got 16q. Therefore, I have proven this equation. Now we have completed the entire questions of model 7.